Welcome to our explainer, where today we're going to get into a process that, and I mean this literally, forges the world around us. From the tallest skyscrapers to the deepest submarines, pretty much everything is held together by the incredible science of welding. So let's just start with a really big question. Have you ever looked at a massive steel structure, a giant bridge, a skyscraper, a huge ship, and just stopped and wondered, how in the world is all of that held together? Well, the answer isn't just a bunch of nuts and bolts. It's a process that uses mind-blowing energy and just unbelievable precision to transform solid metal, literally fusing separate pieces into one continuous, solid whole. Okay, so let's dive right in. The process is called welding, but what does that actually mean? What are we really doing when we weld something? At its absolute core, welding is all about joining things together. The official definition puts it this way: it creates a continuity in the nature of the workpiece material. Now, what that really means in plain English is you're not just gluing metal. You are making multiple pieces become one single solid piece, as if they were never separate to begin with. And what's really cool is that it's not just one person. It takes a whole team of pros. First, you have the welder. This is the hands-on artist, the person with the torch creating the bond. Then you've got the welding operator, who's in charge of the big automated or robotic machines. And watching over the whole project, that's the welding coordinator, the person who plans and supervises everything to make sure it's all done right and, of course, safely. You can almost think of welding as a kind of high-stakes cooking, and every recipe needs the right ingredients. You start with your parent metal. Those are the main pieces you want to join. A lot of the time you add what's called a filler metal to, fill the gap. Then you have flux, which is a super important substance that cleans the joint and protects the hot metal from the air. All the stuff that gets used up in the process, the filler, the gases, the flux, that's all known as consumables. And just like in a Michelin star kitchen, you don't just wing it. Every single weld is based on a super precise recipe and a tested result. The recipe is called a Welding Procedure Specification, or WPS for short. It's the step-by-step playbook. Then you have the proof, which is the Welding Procedure Qualification Record, or WPQR. This is the official record from a test that proves, yes, this recipe actually works and makes a strong, quality weld. So now that we have the basic terms down, let's check out the different ways you can actually weld. Turns out it's not a one-size-fits-all kind of deal. There are a ton of different methods for joining metal. Okay, if you look at this chart here, it can seem, pretty overwhelming. This is basically the family tree of welding, and as you can see, there are so many different methods, each one designed for specific jobs and materials. But don't worry, we can simplify this whole thing down into two main approaches. On one hand, you have fusion welding. This is where you actually melt the edges of the metal. Think of it like taking two ice cubes, melting their surfaces, and letting them refreeze into one solid block. On the other hand, you have welding with pressure. This is where you use force to literally squeeze the pieces together until they bond, kind of like mashing two pieces of clay together so hard they become one. Now, one of the most common types of fusion welding is arc welding, which uses a powerful electric arc to create intense heat. Within that, you've got a few big players. There's MMA, or stick welding. It's super common and versatile. TIG welding is like the fine art paintbrush of the welding world. It's incredibly precise. MIG and MAG welding are the workhorses of manufacturing, fast and efficient. And then you have submerged arc welding, which is an industrial powerhouse for really heavy-duty jobs. Then, over on the pressure side of the family, things get really different. You've got resistance welding. Spot welding is a famous example. That's how most car bodies are put together, by passing a huge jolt of electricity through the metal. Then there's friction welding, which is exactly what it sounds like. You literally spin or rub two pieces together so fast that the friction creates enough heat to fuse them under pressure. It's pretty wild. But here's the thing. No matter what technique you're using, a good, strong weld never happens by accident. It all, and I mean all of it, starts with careful, meticulous preparation. So, first things first, you have to decide how the pieces are going to fit together. There are 5 basic ways to do this. You can have a butt joint where the edges meet, a T-joint, a lap joint where they overlap, and then corner and edge joints. Each one has a specific purpose depending on the design. And you almost never just stick two flat edges together. To get a really strong bond, the edges are shaped, they're beveled. This preparation makes sure the weld sinks deep into the metal for maximum strength. Every little detail matters here. The gap between the pieces, the angle of the bevel, the thickness of the edge, it's all perfectly planned. A skilled welder also has to be a master of position. I mean, it's one thing to weld flat on a workbench, right? But it's a whole other ballgame to weld horizontally across a wall or vertically up a structure. And then there's the toughest one of all, overhead, where you're welding from underneath, fighting against gravity the entire time. Okay, so the weld is finally done. Job's over, right? Nope. How do we actually know it's any good? How do we know it's strong enough? That is where testing comes in. And there are two main ways to find out. First, you've got destructive testing. You take a sample weld and you literally bend it, pull it, and smash it until it breaks, just to see how much it can take. Then, for the actual finished product, you use non-destructive testing, or NDT. This uses cool methods like X-rays or ultrasound to look for hidden flaws inside the weld without damaging it at all. So what are these tests looking for? Well, stuff like this. This is a common flaw called an undercut. You can think of it as a tiny little ditch that gets melted into the metal right at the edge of the weld. And that little ditch creates a weak spot where a crack is much more likely to start. You know, some of the absolute worst imperfections are the ones you can't even see. This is called lack of root fusion. It means that deep down inside the joint at the very bottom, the weld metal didn't properly bond to the parent metal. It's basically a hidden crack just waiting to cause a problem. And here's another scary one. Incomplete penetration. It's exactly what it sounds like. The weld metal just didn't get all the way through the joint. This leaves a critical gap at the very bottom, creating a huge weak point that could easily fail when put under stress. And all of this brings us to what is, without a doubt, the most important element of all, the health and safety of the person who is actually creating the weld. Because this is a process that is full of serious hazards. That electric arc in welding is insanely bright. It produces intense ultraviolet and infrared radiation that can severely burn your eyes and your skin. That is why personal protective equipment, especially a proper welding shield and gloves, is absolutely 100% non-negotiable. So the next time you see a massive steel building, or drive your car, or even turn on your faucet, just remember the incredible amount of science, skill, and safety that went into it. Take a moment and just think about how much of our world is held together by this amazing process of welding.